Hi, welcome to my cabin. Today I'm going to take you through the burglar system that I have done. This is my burglar system. This is a sketch pen holder. This is for my daughter. So I have stolen it from her and I'm using it for my burglar system. So I have connected some 4 sensors with this burglar system, which is connected to the Arduino and the other circuits inside. I'll show you what is there inside the circuit, but quickly let me take you through the sensors and the display system here. Let me switch on my burglar system, and here says welcome you, press menu key. So this is my menu key, and the other keys, I'm sorry, the work is still pending. I have to put a sticker here, and the menus also will have a stickering of what those buttons are. It is just incomplete, but I just wanted to show you the burglar system, how it works. So this is my menu key, I said. So it says LDR, so light dependent resistor. So my LDR is connected to this burglar system. I have a connection here. I'll show you about the slots when I show you inside the circuit. I'll show you about that. So I'll take you through the LDR sensor which is connected here. Yes, this is my LDR sensor here. So this is a PVC bottle. So this will be kept outside my house. So the sensor is here. I don't know if you can see the sensor. Sensor is here, one, and one on the top, the other one at the rear. So 3 sensors. This sensor will be kept facing east so that the sun rays, noon and sunset will be completely observed, and this will inform the burglar system about the darkness, about the light falling on the sensor. So using that, I'll be able to sense what is the brightness outside, and if it's too dark, I will switch on my lights if it's too dark in the evening. So even if I am not at home, this will automatically switch on my relay, and the outside light will get switched on till 9 o'clock. So once it's 9, the lights will be put off automatically. So this sensor, this is a cement plank which just can withstand sunlight, waterfall. So let me show you what is the status reading in the LDR sensor. So let me read what is the LDR sensor is showing now. So it says the upper row is saying D, which is month, day and month, time 7.91 by 10%. So out of 10%, 7.91 brightness is there. It is saying day, and this one's technical about the relay configuration. So if it's day, let me make the sensor. Let's do one quick thing. Let us close this sensor with a piece of cloth. Now it's dark, so there's no sunlight over there. And see, let's check that in our status here. Yes, now it's saying 0.21 out of 10%, which is night, and you have the date recorded here. So 5th of April, time is 1:09. So which means so whenever there's an incident occurring, like if it's going to be dark or it's going to be sun rays, those dates and time will be recorded here. So suppose you want to know end of the evening what was the sun rays timing, you can actually come to the LDR here and then look at when was the sun raised, and again when was the sunset also. So now it's night, so we need to have the power also lights on. So here I have technically a relay which is here inside. I have an LDR LED connected to it, which means it's getting switched on. So my power is switched on because it's showing night, so it's getting switched on. Yes, now let's go into our next project, PER sensor. Okay, PER sensor, let's look at the status about it. Okay, which means my PER sensor is here. So this will start its detection after 9 p.m. So when the LDR switches off the light outside your compound or in front of your house, wherever you're going to fix your lights. So once that's the work of the LDR is finished, then the PAR will detect the movement, and this will automatically switch on the lights if there's any movement detected. This will switch on for 1 minute and then switch off after 1 minute. So now because it's light and we need to have 9 p.m., not just darkness, so it needs also to be dark. Only if it's dark, there's one particular code which will send to the PAR for it to work. Even if you're going to make the LDR dark and make it work, it doesn't work because it has to be 9 p.m. So I'm going to, but how are we going to see what is the status here when there's a movement here and what PAR is going to see? Yes. Now it says there's no date, nothing is recorded, so no movement. So R2 equal to 1. Why our R2 is 1? Because of the LDR. Let me switch it off. Let me take an update. There's no movement. Our relay 2 is 0. There's 0 first digits is the sensor value. So I'm just going to make a movement here. Just yes, one move detected. R2 is at 0 because it's not 9 p.m. So so only when it's getting switched on, the date and time also will record. So I will know when was the PAR recorded, what time the incident had happened, what date. This will be recorded until the next incident will happen. That date will be recorded here. So this is my PAR sensor. So next we'll go and get into water tank sensor. So I have a tank in my second floor and I'm in the ground floor. So I wanted to use a sensor which will actually sense and tell me how, what is the level of water in the tank, and which will also help me when there's a low tank water. So it will also help me with some kind of a beep for 10 seconds or 20 seconds, so that I know that the water is very down and I'll quickly switch on the water. So in this way, whenever you know that the water is low, which will sustain for another you will quite have some 100 liters of water, so this will give you an alarm, so you can switch on the tank. So this is my sensor. So this is just a PVC. The wire has been connected here to the burglar. So I'll show you this. There's a nut here. It's an aluminum nut which is a pointer which will detect the point. So this will sense this is a tank full for me according to mine, and so this is 75% of the tank, and this point is just 50%, and this is 25, and this is 10%. So I have a wire here. So let's assume that this is water. Okay, the water is like touching the points. Let me first see what is the update here. Update, this is a sensor value. 449 is the sensor value. So 111 percentage, for my understanding, it says the circuit is open, which means it's not connected inside the tank. There's no the water is not connected to it. So if it's going to show you open, you can either think that the wire somewhere is disconnected, the circuit is open, and so you have to connect it, recheck and then connect it. So R1 is just a relay. It's a bus actually. So let's see what is the tank level now. I'm going to touch here. Okay, this is 75%, I said. So I have to keep it continuous connected, not just a touch. And let's now see what is the level actually. Okay, it's not connected properly. Let's connect it properly. Okay, it says 75%, 3/4 of tank. R1 is at 0. R1 is a buzzer, so it will not buzzer when it's 45%. So let me say that I'm running the tank and water is filling the tank, and if it's 100%, so this is 75% and this is 100. So I'm just going to touch this. Let's see if it's going to beep. Can you see the beep? Yes. Let's leave it like this so that you can see in the sensor. So it will have a ring for 20 seconds, but then it will be in a prominent place. It will take my attention. So then I will switch off the the water tank. Let's see what is it showing here. Okay, it's showing 100% now. So it's just recorded the date and the time here, and 899 is the sensor value. 100% full, R1 equal to 0. So it stopped beeping, that's why it's showing you 0. So let's see the low level of the tank. Okay, so water is just dropped to this level, 25, and then it's going to be 10% here. I'm just going to touch and see what's the level. Let's see what's the level of water now it's showing. Yes, it's showing 10% low. R1 is beeped. So this is the time of occurrence. This is the level. So the point is like between this 100 and 75%, there's a resistor connected here in between here, and there's a resistance wire here, and there's another resistance wire and resistance wire. So I have already done the wiring for my tank with 2 wires. So I was not able to pull out another 2 more wires for ultrasonic sensor to be connected. So I've just managed to do the thing with just 2 wires by having a potentiometer, so power divider. So I'll show you how I connected the power divider here. So I'm able to sense the potential difference of voltage between these points, and which is able to the burglar system is able to measure the tank level by the potential difference of voltage. So I have done my three sensors. I'm going to show you one more sensor, which is a remote control, RC control. So let's see what's this showing up. You know the technicality. So the last time when I switched it off, it was 122. So it is showing me 122. I have operated the remote, the date and the time. So this is the remote here, and so this is my IR sensor. So it just not packed, and it's not designed, put in the cabin and things. So I'm going to operate this. So this remote will give you the buzzer. Let's just to check the buzzer is working. Maybe this battery is weak in this remote, so I have to struggle a lot for pressing. So which means it is pressed here. So I'm going to switch it off. So I can do all the testing. I'm going to switch on my relay 2 here. So you will see an LED here glowing. Can you see the LED here? Yes, I'm going to switch it off. Switch it off. So again, this third button will just give you a buzz for every 100 millisecond it will beep and then stop. Same thing, this is for the remote. Can you hear the beep sound here? So every 10 millisecond switch on and off. So put that off. So this is the off button. So in future, if I had more projects, more things to be connected, I can use the other buttons and operate the any device, like I have a trail gate, which in the future I can connect a motor and operate this in my car, and then make the gate open and then close. So that was the purpose. So I've just created this as well, just to check, operate things. So if required, you can connect to operate even your household things, like anything else that you prefer to do. So I'll show you what was the buttons that we have pressed here. So this will also show you the hexa value, which is we only see the lights actually. We don't see the what you call the technically hexa value. The remote, every button here has a value, which is going here to the IR receiver. So the button will know what is that value is being pressed, and accordingly program is being done. If it's this value, you do this work. If it's this value, you do this work. So what is that value? you will be able to see in the serial monitor, but however I have managed to put it up here as well. Okay, this is the sensor value. So the last time I have used the sensor is 126. R1 is the relay status, R1 relay status, R2 is relay status. So both are off. So I'm going to switch on one here. It's going to be, let us say R1 should be 1 now. R1 equal to 1. There's some technical problem here. FFF, which I actually need. It was showing the EXA value. I need to check my codes again. So now R1 is beeping. So that's why it's showing 1. So let's go into our next. The next menu will be time 5th. Let's see what's the time date. 5/4/2020, 1:27:31 second. So the timing is done with the RTC. RTC is the real time clock which is connected to the Arduino inside. So this is actually keeping up the date and time set. So I've used the battery is connected to the RTC. People who know RTC will know that the battery is connected to the RTC, which will maintain the real date and time which has been programmed into it. So that's one. And let's see what there in output monitor. Here I'll be able to monitor all the outputs. Like R1 is the technical information, but I'm trying to keep you informed about it. R1 is the status about the buzzer, R1 buzzer, and R2, and L is for LED. What is the status of LED? We haven't removed our cloth here, so let's remove this and see what is the update now. Just 0.21. Let's see, it's going to show 7 or 8 now. 8. Okay, 8 out of 10%. P is the PAR 0 now. Water tank 111, which means I have not connected it now. It's just lying here. So so this is the 8th menu is the GSM GPRS, which I haven't connected now because already I have done with the 2G SIM. It was working very perfectly, and now no networks are operating with 2G. So there's a connectivity issue with the GSM port 800L, so which was something I was using. So I have a connectivity issue with that. So I have disconnected that now. So let me try with some of the new models if it's available in the market with 3G or 4G thing. But right now, to my knowledge, it's not available in the market that I purchase. So in the future, if there's something available in 3G and things, I'll have to purchase that. About my burglar system. So this will be kept inside my home, outside corridor or inside. I have to choose that now. Let me quickly take you inside what is inside this. Okay, let me open up now. So these are the components inside. So I'll explain to you one by one. So this is the power source, plus and the minus. This is connected to an external battery here. This is my car battery. So I've recently replaced my car battery, a new battery, and I didn't want to throw this battery because they were charging only very less in return exchange. So I wanted to use this for my project here. So it's a good idea now. I feel that it's very useful for my Arduino board because this has 50 amp 12 volt. So 50 ampere, the Arduino will probably need 20 to 40 milliamps. That's all. So this is 50 amp. Imagine it will work for an year even if it's not charged. That's my calculation. So you can connect this connect Arduino Burglar system with this battery, or else I have a solar system here. I can even connect this with my burglar system. So now I have connected this to the battery. 12 volt is here, and there's a power switch on, just to switch on and off the power. And here I have a regulator, 12 volt regulator, just to because you know that these are voltage sensitive devices. So you just need to maintain the voltage, input voltage, that exactly that it needs. You cannot go exceed even a 1 volt or 0.5 volt. So I'm using a sensor. I'm very careful about it. So I'm using a 12 volt here just to regulate, and I have a fuse here, and this is a 5 volt regulator. I have a fuse again here. So these are relays. I have a 12 volt relay, 12 volt relay, 5 volt relay, and the other components are nothing but the transistor to switch on this relay, and these capacitors are just to maintain that the flickering of the relay, and the other thing, the other components are all connected to this. There's an Arduino here. This is a display with inbuilt push buttons, and here I have an RTC which has a battery backup at the back. So this will keep up the timing of the Arduino, the date and time of the that we have set. So even if I'm going to switch it off as many times and switch it on also, so it's going to maintain the date and time to the Arduino. So that's about it. This is the buzzer, and this is the USB, which I can even connect to charge my mobile phone or any other batteries. And this is my AC power supply, which will be connected to the output of the relay. So this I have to take it to the AC old supply. And so here I have a PCB connected. These are the input output slots which are going to be connected to the Arduino. So this is a PCB etching that I have seen in YouTube, and I tried using my own PCB design with the chemical format etching method. So I purchased this board, and I just wanted to have a try. I have done this, and then I used a drilling machine to make even small holes, and so it's not so much professional, so not neat. I'm not satisfied about the work, but BAMing, this is the first time that I've done. So I have designed it in such a way that the input output is connected here, and outside you have a slot, which I'll show you now. You have a slot here. So these are slots which will be like you can remove this off like this. So you can even remove this off. There's male female connectors here. So 3 pin, you have a 4 pin connector, 2 pin connector. So all these are connected here. So you can remove it, and you can use like a suitcase. You can carry it anywhere you prefer, or even you're going to take it to the school or somewhere where you're going to give training. You can use sensors here and then give the testing, and they can see the results here, and the circuits can be explained to them. So this is the project, and I hope I have covered everything. I have to show you the codes now. Let me take you to my computer inside. I'm going to open up my Arduino. So this is my sketch for the burglar system. Too long sketch. So I'm going to quickly run through the sketch. So in case you're not able to follow up or understand the sketch, I'm going to provide this sketch for your download. So click my description, and you will find a download link which you will download from my drive. Yeah, so let me quickly describe about the sketch, the important things in the sketch, the other things you can follow up. So I have used these libraries, so RT clip, IR remote, liquid crystal, RTC, DS1307 liquid crystal. All these libraries are easily available. Just Google, and then you can download. So I have used these define right button, left button. This is for the LCD's inbuilt push buttons. Like I was using menu up down buttons for those things. So it is the inbuilt button is connected to the analog A0 pin, which is actually works as a potential difference. So the voltage difference is measured here. Like if it's going to say 1000, this is for the inbuilt work. So we're just going to say if it's going to be more than 1000, it's a none button, right, left, down, left, select. So again that's over, and here I've initiated my variables here. So I'm going to use up, down, constant string. Here I've used an array, null, LDR, PAR, water. This is for the menu.
So as in when I press the menu and then up down, so this is going to be my next script. And so here I'm using a matrix 2 row and column array. And the other things which will be part of the sketch, you can go through it. So I was very particular about defining a variable, whether it's going to be integer or byte. So if it's going to be more than 255 number by number, so I'm using byte. If it's going to be higher than 255, I have defined it as int. See, you look at here, my compiling this thing. So already my 72% of my dynamic memory is gone. So I am left with only 553 bytes for my local variables, and the sketch uses 16,650 bytes, which is 51% percentage of the program storage space. I don't have. That's not a problem for me. I still have more 49 percentage, but 72 percentage, if it goes 70 after 75 percentage, you cannot assure that the board will work properly, because there may be internal two functions work together, there may be some clashes. So Arduino definitely will need something no less than 75 percentage, or I would say even less than 50 percentage will be better. But in my case, so I had I had to run through all the four sensors. So I have to use all the variables here. So defining them, whether it's going to be float or byte, so I was very particular. So byte takes no no the space for byte integer is all different. So based on that calculation, I have done the variable definition. So setup, so I have defined my pin mode output, which is my pin input and output. That's all basic. So here void loop, I have used LDR, PAR, water tank, IR, car remote. So these four functions are going to keep on running. The trick about here is, so if I'm going to display my LCD messages within LDR or PAR, so every time my display will start showing LDR, PAR, water tank, IR remote, no, it will get collapsed. So here I've very particularly used function and a call function, which will work only when I call the function. So here I have used menu. So initially when you start the burglar system, it says welcome you, so press menu key. So initially I have defined up equal to 0, so it's going to be 0. So initially this will open up. So once I press my menu key, so there's a change there. So once if I press the menu key, my which is LCD key equal to 4, then I'm doing my up equal to 1, then I'm displaying press menu again to confirm. So this is, how the LCD displays. The first line is 0 0 and 0 1 is the second line. So here I've used the screens up is the 1. So now up equal to 1. What is my 1 here? Screens, let me go back and show you this very quickly. So screens 1 is, so null is 0, this is 1. So if I do up another one, it's going to be 2 PAR. Likewise it's going to work. So I have done up, then after when I confirm it, it's going to be here. So I'm saying if it's going to up key, then it's like greater than, it's going to work between 1 less than 6. So up plus plus, again it's going to switch here, which is PAR. It's going to show you PAR in the display. So likewise all other things are going to when you press up, it will be up. When you press down, again it's going to come down, count down. So once I confirm my suppose I stand with PAR and say OK, my OK comes here. So I'm saying press OK again. So again when I press OK, that is taken for my select. So if I'm selecting at 2, say if select equal to 1, it will take you to delay LDR. It will take you to LDR function, and here I said display data select. Here is where I'm going to show the result of my LDR status. Again LDR select to PAR, and then it's going to take display data. Display data is a call function which is going to take this 2 there, so which means I know that this belongs to PAR. So this is the second. So I'll take you through display data, but before that let's go to the sensors, and then I'll come back to that last. So byte LDR is equal to, I'm going to I'm calling the RTC, initiating the RTC here. I'm going to use the RTC time inside this function, and so I've used integer. These are formulas. A1, I've used A1 for LDR sensor. LDR A1, across A1 I've used 1k resistor as a power divider, so which means 1k across A1, one will be connected to A1 and the other end of the resistor will be connected to plus 5 volt, and again another resistor with connected to A1, it will be connected to the ground. So that's the power divider. So so doing that, then my float, while I'm doing a simple calculation, this is to measure the potential difference of the voltage across the A1. No, it's a basic formula. So next I'm multiplying this by 2 because I found this it had a very small number, even less than 1. It was in float value, so I wanted to multiply that and make it a complete numeric value. So here I'm using 1, this is the row, this is the column. Column 5, 1 will store this LDR detect. If f equal to true and LDR equal to less than 1, I'm saying if it's less than 1 is only during night time. If it's night time, this will record the time. So now date will record to 1 1. Now month will record to 2 1. Now hour will record to 3 1. Now minute will record to 4 1. So it will store in that matrix. So whatever is that. Then I'm saying digital high, and then Gurkha is false, F equal to false. These Gurkha false, this is for the PAR. So once I say Gurkha is true, only then my PAR will start working. My PAR will start work only after 9 o'clock when the LDR has done his work. So now if it's dark less than 1, F equal to true is just to ensure this the loop runs only once. So I'm saying F equal to false. So once it switches on, so this loop will not be executed again. So it will come to here. If now dot r, which is r is greater than equal to 9, 21 is 9 o'clock, and f equal to false. F is obviously false, but initially it's not false. So digital, this is not required. In case you can remove this, but I have used it here. You can remove that as well. So my digital write will be low. So I'm switching off my lights. That's the relay 2 after 9 o'clock. Again I'm saying my Gurkha equal to 2. So Gurkha 2 is, I'll show you where this Gurkha goes to. If LDR detect is greater than 2, which means it's a day, so night has passed, F equal to true, F becomes true. So F becomes true, so until evening this loop will not be executed. Once it's dark, this loop will be executed. So I'm saying, so again once it's day, sun rays, so again the datas are replaced here. 1 1, now date, now month is all replaced here. So that's about LDR. LDR's work is done. So let's go into PAR. Again I'm initiating the RTC here. So PAR sensor A2 is connected, pin number A2 is connected to the PAR device output, and display 2 by 5 is PAR sensor. These I'm using just for the display data to display this sensor value of the PAR. If PAR equal to high, I'm saying motion sensed at day. It will be, if it's sensed, it will be day. But if LDR is sensed, LDR equal to 1, if it's night, and Gurkha equal to true, which means it's night after 9, then I'm saying motion sensed at night. However, even less than 9 o'clock, according to the sketch here, I would consider that as a day. So after 9, when Gurkha is equal to true, it becomes night. So display 2 and 1, now again I'm registering the time, the movement, some movements have taken place during this time when it's dark and it's after 9 o'clock. So those date time is recorded here, and relay is high. Day period equal to 2. Day period is for the display data, just to tell the day data sheet that it's a night. So and I'm switching it on with 30 seconds of time delay. So until 30 seconds the light will be high, after that it will go low. See here I have used delay. Earlier I used millis, but somehow I don't know if some of you can comment about it. It's very good because of RTC connected to the Arduino, my millis was not working at all. I somehow tried this. I even worked for many days about working, because I've done with a different project for an LED switching on and switching off with millis function. It was working, but when I brought the millis to work here, it was not working. I somehow got fed up with that, and I dropped. Even I've tried using the now dot second just to switch on for 30 seconds and switch off. I don't know. I was finding very difficult about switching, keeping it switch, because after 59, no, the time period will be 01. So I had some difficulty about the count here, and I did all my tricks to even count in it, but somehow it was taking up my days, and I gave up. I didn't want to take much time of it, and so I've simply used the delay here. If you can try with millis, it'll be good, and if you can try and share the codes again with me, I would appreciate. So again, else day period equal to, this is for the data sheet which I'll show you. Then water tank, again time is called up. A3 pin, analog pin, A3 is connected to the water tank. Water tank, again I'm using that as a power divider, which means I'm using resistance across A3 with positive voltage and with ground. So one end of the resistor will be connected to the +5 and other to A3, and again with ground. So after that, I'm using this as a potential divider to measure the voltage difference across each point in the sensor. That you have seen the sensor with 5 points. So across each sensor there's a resistance. So there's a 5 volt which is passed to the water in the tank, and so according to the raise of the water, the resistance also is merged into the water. So which means the resistance is no more, that is substituted. So likewise, I'm calculating this thing. If water tank is greater than 800, and so if it's greater 800, the water is full. W equal to true is because I'm trying to run this loop only once. So this is run here. I'm keeping it high, delay for 20 seconds, and I'm keeping it low, W equal to false. So this loop will not run anymore. So once it's beeped, it will not ring beep anymore, even if it's greater than 800. So that's one. And so the other things is all about water tank with potential difference 650. The sensor shows 650, between 650 and 700. I would say it's 75%. W equal to true. I'm enabling this now here. So after coming to 75%, if I switch on the motor, if it's full, it will tell me that it's full. 75% I said. Okay, water tank is 75%. Again 550, 580 to 630, 50%. So 25%. So again my K, something that I'm using is K equal to true. Even K is equal to true, just to keep the loop run only for once. That's why I'm using a boolean here with true. So K equal to true. So when K equal to true, the water tank is 10%. And so you can use the serial monitor in case you want to see the complete description of this. So I'm using a display 132333 to store the date and time of when the water in the tank went low. So it will ring, the buzzer is high, it will only buzz, it will not switch on any power supply. So it will be for 10,000 milliseconds, so which means 10 seconds. So it will be low after that, and I'm putting my K equal to false, which means this loop will not run after once. So if I'm saying water tank is less than 450, I'm using just any number. It could be any number, but I'm for my for my knowledge, I'm using 111. So when I see 111, I'll know that it's an open circuit. It's not connected to the water tank. So that's one. So next is the IR remote function. I'm using the RTC call initiated, and I'm saying if IR receiver code, this is a default thing. So I'm using that. If it's available, go there. and so print the value there. So this initially will help you to record the value of each button. So initially you need to operate all the buttons, print the serial code of each button, keep that written on a piece of paper, and when you write the code, use that particular button. See, I'm showing up results dot value equal to is an XR value. So if this is the value, this is the value of the button that I'm using, which is L1 in my remote. So this button, when you receive, I'm saying when you receive the IR sensor receive this code, particular code, you do this function. You put the high, buzzer high, and it will also display in the serial monitor that I am L1 button. And if it's this code that you receive, which is L2 button in my remote, then you put relay 2. Likewise, each button will do one function, and I am putting it off also with one button, R1 and R2, everything is switched off. And here again RTC function, I've used the date and time to display with the now dot month, now dot here, same thing. So display LCD cursor 1 and 2, second line. So output monitor, I've called used all the sensors value to be displayed here. So buzz 1, I'm using the buzz 1 buzzer 1 value to be shown, R2 relays status here, and then a second line L means LDR I said, so LDR's value will be shown up here. Then P is for PR water tank, everything will be shown here. Then I said GSM SIM, so this GSM I'm not using, is still under construction. This is a very hard worked code actually, so remember that I've nearly taken 1 year to complete this. So imagine the kind of errors that I had, and each line by line I had to go through the internet, find out what is the error about. And so because I started the Arduino myself from the internet, so internet is the only place where I can go and again dig into my knowledge. So all these whatever I have done is from the scratch, I learned from the internet, and I wanted to give back something to the people who would help me to develop so much with the Arduino. And this is a small project. Thank you for watching this video. Do subscribe to my channel, and any comments please share below. Put a like button. Thank you for watching. Thank you again. Love you.